Alright, so what we're going to do now is finish off division by doing some problem solving division, some more advanced concepts of division. So, first of all, remember the new definition of division again. What's the new definition?
A times
A
1
divided
over
by-
b.
Yep, A times by the reciprocal of b, which is 1 on b. So that's a very important definition we're going to use a fair bit, right? So, we're not going to use it all the time, we're going to use it when we can. But the idea here is this. So we have a question like this. Take a look. I want you to think about this for a minute or so. 123 times by 64 divided by this whole thing. So maybe write some things out. What's your ideas?
Do I do it?
You try to see what can you think of to do, yeah. By the way, do you want a pencil?
Huh?
Do you prefer? Do you like friction pens?
Yeah.
Whatever you prefer, it's fine. Because I think you can rub it out, right?
Yeah.
Okay, so you're on the right track, and you will get the right answer that way. But one thing problem with that, what you're doing right now is you're multiplying these two together, finding the answer of that, and dividing by whatever this thing is, right? That's kind of big. And most problem solving questions aren't like that. There's a shortcut. So it's up to us to find that shortcut. Do you see any relationship between the two sides? Between the numbers you're multiplying and your numbers on the left side of the division and the right side of the division?
They're both timesing with 123.
Yeah. So what happens when you divide? So you have 123 multiplied here and you divide it on the other side. What's 123 divided by 123?
Oh, 1.
1. But why do they cancel out? There's something in between.
A multiplication.
Yeah, but it doesn't make sense why they're not next to each other, right?
Yeah.
And here's how you can move it around to make it next to each other. I'll show you how to do it, but you don't have to move it around, but I'm telling you can cancel it, but probably anytime I tell you something, you should wait for proper justification, right? I'm telling you cancel it, but you should trust it. And I will show it to you, what we do. Oh, it's so big now. That's so if you do that, you cancel this one and this one, and you end up 64 divided by 16, which is pretty easy to do, right? Well, you shouldn't trust it, so I'll show you why that is true. What's actually happening is 123 times by 64. If I expand out the brackets, the division will distribute to both numbers. Divided by 123 divided by 16. Right. So then I can't move the divisions around, but what can I do? I can convert the divisions into
Multiplication.
so 123 times 64 times by 1 on 123. The multiplications aren't convert to multiplication isn't helpful, but what it does is it helps us move it, because multiplication you can move around no problem, right? What I'm going to do is I'm going to move this around to pair the 123 with the reciprocal. I'm going to switch these two basically. So it ends up being 123 and 64 times by 1 and 16. Then I'm going to go back to division, because these are, I don't know, multiply and reciprocal, same as division, right? Convert to division again. And when that happens, 123 divided by 123 is
1.
1. You have times by
Times by
64,
64 divided by 16.
which is
4.
4. that's a proper proof behind it. But if you want, you can just go like, oh, I know it's going to cancel out because everything in this divider is going to cancel out nicely. I can just be like, immediately be like, oh, this cancelled. This 64 divided by 16 is just 4. So I can divide whichever ones on either side of the division, as long as they're multiplied. Addition doesn't work exactly, but if it's multiplication and division, you can always just think of it two sides, right? Same thing here. 120 times 63 divided by 60 times 9. How would you approach this one? Very similar to that. So I don't want you to do all this working like me, but if you get the idea behind it, you can cancel out quickly.
Yeah. I would turn the division to a multiplication.
Yeah.
And then take the 60, swap it around with the 120.
Yeah. Swap it with the 120 or swap it? You want to bring it near the 120?
Yeah, like.
Yeah. So you switch it with the 63, right? Then you get.
Oh, yeah.
But your idea is you want to pair it up with the 120.
Yeah.
Yeah. Okay. And then what happens when you do that?
And then 60, you do 120 times 60.
Was it times?
Or divide, I mean. Yeah. And then that is
how many 60s are in 120?
2.
Yeah, 2. What about these two numbers now?
You divide them as well.
What do you get?
Which is 7.
You have 63 divided by 9, 7. What do you do with these two numbers, 2 and 7?
You times them.
Yeah, 2 times 7.
Which is 14.
So you see, you avoid a lot of work, you get nice simplifications. Now I want you to do these two by yourself. Well, when does your soccer finish?
My what?
Soccer?
Today.
No, like which day? Like, is it, what's the last game of the season?
Next week.
Next week, alright.
I'm not sure what time though, because it varies.
Oh yeah, that's fine, yeah. I mean, that's next week's last week.
Yeah. Um, 20.
How'd you get 20?
First, I noticed that 21, 19, 17, and 13 had the same in each bracket, and they all equal 1 if you divide it, because it's opposite. So when you add them together, you get 4.
You don't add them, there's no additions anyway. It's 1 by 1 by 1 by 1. So here, you had a 1, you didn't. Oh, I see. I think you're getting confusion because there's 4 1s, but they all be multiplied together. It's like 1 times 1 times 1 times 1. They're not being added together. So if you multiply 1 by 1, what do you get?
1.
So they don't change anything. So it's like, what's happening is, if I show it properly, what's happened is I move it around so that I've got 13 divided by 13 times by 15 divided by 15 times by 17 divided by 17. You shouldn't do this because it's long, right? But 19 divided by 19. Oh, sorry, not 15, it's a cancel. right? So it's 13 divided by 13 times 17 divided by 17. This 2 multiples, get rid of that. So 21 divided by 21. These will cancel, right? 13 divided by 13 is 1, times 1, times 1, times 1. And actually at the end there's 15 divided by 5, divided by 3. So it's all multiplication between them.
So it would be 5 times 1.
Yeah, bunch of ones.
Yeah.
It's just
5.
5. So the reason we don't add, there's no additions anywhere. So you only add when there's addition symbols. So yeah, that's the reason. And what about D?
Oh yeah, I haven't done D yet. Is it 2?
How many of them are there? Because when you have a bunch of ones, they multiply. They don't do anything. When you have a bunch of twos, it's not the same. Because if you multiply 2 by something, it changes the value. How many 2's do you have?
4.
And what are you doing to them all?
Times them by 2.
You're timesing all of them together. So it's like 2 times 2 times 2 times 2. Because remember, the number operator between them is multiplication. The dot means multiplication.
Yeah.
So it's 2 times, which would be, if you multiply all the 4 2's together, what do you get?
8.
No, 2 times 2 is 4, that's 2. 4 times 2 is 8. Just only 3 numbers. That's only 3 2's. We're do another one. 8 times 2 is?
8 times 2 is 16.
So that's 16. Does it make sense why there's 16?
Because, like, if you double 16.
If you double 8, you get 16. If you double 4 times, you get to 16. So what you have is 20 divided by 10 is 2, right?
Yeah.
24 divided by 10 is 2. Times 28 divided by 14 is 2. Times 32 divided by 16 is 2. 2 times 2 times 2 times 2. And if you do this slowly, what do you get? Be careful, I think you just made a silly mistake actually.
16.
Yeah, that's why we get 16. Right? So it's not too hard, you just gotta be careful, because when you multiply the same number a lot of times, a lot of people tend to miss 1 or 2 of them. And then they might even do extra. So a lot of people overshoot or undershoot. So you gotta make sure you multiply 4 times. Or 3 times actually, but there's 4 numbers. So that's that section.
Yeah.
And to be honest, we skip this section because it's not as useful. So we might honestly skip it here as well, just because we figured that we'll come to that later. We need to. What we do is we go to exponents now. Right? So we'll go to powers, which is that handout. So let's go.
What time did this class start?
Our class is about 3. So we're moving a lot faster because it's just get rid of this stuff. Have you done squares before?
I remember we did a bit of it in grade 4, but we didn't really go too much into it. We just did it.
Oh, okay. Like the really basics.
Yeah.
Alright, so a square is a pretty simple idea once you get used to it.
Yeah.
But before that, let's do a couple examples. You do this multiplication at the start, which is 4 times 4 and 23 by 23. Dabbing water. Yep, just like you did. 4 by 4 is 16, correct?
324. 324.
No, careful. It's odd numbers. How did you do that? Long multiplication.
Yeah.
Just be careful. I think you made a couple silly mistakes there. 23 times 3 is.
No. Was it 329?
No.
That's right.
The last two numbers are good. 23 times 3 is what?
23 times 3 is 69.
Yep. You can do one by one. 3 times 3 is 9. 3 times 2 is 6, or 6, 9. And then you carry the 0. 23 times 2 is what? Get to here. 2 times 3 is 6. 6 here. 2 times 2 is what? I think you made a silly mistake. I think you know exactly. There's
2
nothing.
times 2 is 4.
So it's not 2. You put 2 here. So 23 times 23. 3 times 3 is 9. So it's 6.
6.
3 times. Do you have 2 now? 2 times 3 is? This 2 times 3?
6.
6. 2 times 2 is?
4.
4. 460. You add these together, what do you get?
500 and 529.
529. But you just missed the extra 2 there, so that's why. But it's pretty simple, right? Pretty basic multiplication. But what we did here was squaring. We did here square. Because a square is defined as...
Timesing itself.
Yeah, it's a number by itself. So a squared is defined as a times a. Right? So keep this in mind. It's a very important definition. I know it's a basic definition, but there'll be other times where this definition comes really handy. Alright? And in maths, definitions are very important. If you understand definitions, you'll be good at maths. Alright? So now can you calculate the following squares then? 9 squared and 37 squared.
37
Careful in your long multiplication.
Yeah.
Because you obviously know how to do it, but just gotta cut out the silly mistakes, right?
Do I do this one as well?
Yeah, do this as well, yeah. So this one is 9 times 9, which is 81, like we got. Part B is 37 times 37. If you do the long multiplication, you get, like you did, 1369.
369.
Good. Seven times 7 is 49, like you did. Good.
576.
Yep, 24 squared is 24 times 24.
Oh, just keep it there.
If you do long multiplication, it's 576. Very good. So you got the idea of squares.
Yeah.
Nice. Now we'll go to a table of perfect squares. So the reason I put the table here is later on, not in this topic exactly, but you might need to recognize squares. There's some theorems and stuff later on which you learn, which have squares in them. So if you can recognize squares immediately, if you see like, oh, if you see 16, oh, that's 4 squared. If you can recognize that, it's pretty useful. So for the best way to do that is to know your squares, or to memorize them. But don't just memorize them normally, like just be like, oh, I'm going to memorize the first 10. Don't do it that way. Don't just try to memorize them aimlessly. What you do is, whenever you have like, I don't know, 7 squared or 12 squared or whatever, and just be like, oh, hey Siri, what's 12 squared? Or don't Google it even, right? Calculate it yourself. If it's like 423 squared, obviously use calculator. But if it's reasonable, if it's within 1 to 30, you don't know what it is, calculate it by yourself. Once you do enough calculations by hand every time you don't know it, it just comes to memory. You'll become super. You know it then, right? A lot of people try to force themselves to memorize, but when you force yourself to memorize maths, it's not really that good. You're gonna get, because it's maths about using it, and to use something, you don't understand it. Memorizing is not enough, right? So that's my thing I want to tell you, is that whenever you have like square to do that's not huge, try to do it yourself, right? I've got, I think, because whenever I don't know a square calculator, I've got about maybe 50, up to 50, I don't know. So it just over time, you'll just get more and more, right? Okay, so now we'll go to this actual proper section, which is the next section of questions, which is when you combine squares with other operations like multiplying, adding, subtracting, stuff like that, right? But when you do that, you got to follow the bid mass rule. So what do you use? Is it bod mass you guys use?
Yeah, basically that.
Yeah, whichever one it is, but it's the same thing at the end of the day.
Brackets, indices, division, multiplication, addition, subtraction.
Yeah, so it's brackets, indices, division, multiplication, addition, subtraction, right? And another key thing is that difference between division and multiplication. Does division come before multiplication?
Yeah.
They're the same. They're grouped.
Oh, yeah. So is addition and subtraction.
They're grouped. So brackets is first, indices is second, which is like powers. By the way, indices means powers, right?
Yeah.
You know that? Yeah, good. So all the indices you do before.
Wait, is indices the same as order?
Yeah, indices, order, called exponent, which is a or power. The reason they don't put a P is just because it doesn't sound nice.
Yeah.
Yeah, this was because I, O, E, they're all nice vowels. P, and they can't do that, right? So they only use. That's why they use all these complicated words, because power doesn't really make sense.
Yeah.
They sound nice. And division, multiplication together as 3, and addition and subtraction together 4. I know you know all this, but I want to reiterate this because we'll be using this very, very thoroughly, properly in the next few questions, right? So you go to the next page. Here. We have all these questions involving multiple operations. So you got to do the right ones first. So if you want to write down the bit mass, but you don't have to if you know it. I want you to calculate these questions, right? I'll find the answer to these ones, but I want you to do it properly by doing the right operation first. So go through bid mass, right?
Oh.
Is there brackets first? If the brackets, do whatever's inside bracket first.
Yeah.
Then I. Oh, is that indices? Let me do that. Because maths at the start, it's a bit boring because there's a lot of rules to follow. But trust me, keep looking at it, it gets a little bit more interesting. And then it gets boring again. And you go to uni, but you don't need to go to uni and do maths. Mm. 102?
Yeah.
Good. So it's 160 minus 7 times 9. You keep going with the next one. I'm just going to explain for the video. 7 times 3 squared is 9. U square first. Then 160 minus, you do multiplication next, which is 63, I think, 7 times 9.
What is this? Is it 4 squared?
No, it's inside bracket first. You value the bracket, then square.
Oh, so you do the square of the answer?
Yeah.
Oh, yeah, okay.
And when you do all the subtractions here, 97 plus 5 is 102, like you got to now.
Yeah, 77 would be.
Good. If you calculate this, it's inside the bracket becomes 12. 12 squared is 144 divided by 2 plus 5 is 72. Oh, just write this properly for anyone watching online. 144 divided by, keep going in 2 plus 5. It's 72 plus 5, which is 77. So what did you do here first?
For this?
Yeah.
9 squared is 81.
Yeah, do the squaring first. Bid mass.
And then I'm doing the divide by 3 now.
Good.
Which
that.
is...
You get...
Which is... 19.
Long divide if you're struggling. Long divide does work here because it's if the number answer is bigger than 10, long division will work. Yep, 81 divided by 3 is 27.
7.
With these subtractions. And if you have all the same operation, what you do? If I have like only subtraction and addition,
left to right.
Left to right. You can do right first, but you could be very careful. Because some people do 27 minus 8, which is 19. That'll be wrong. Go left to right. I'll show you the other way if you want later. So go left to right. Left to right will always work.
Uh, 181.
Ooh, you go left to right is the question. So you have 200 minus 27 minus 8. So you go left to right here.
You have to.
If you go this first, it's minus 27 minus 8. It's going to become a bigger negative number is what you should do.
Yeah, that's what I did. I accidentally
did. You get 19?
No, as in I minus 27 by 8, and then I got 19, and then I minused it by that.
Oh, yeah, because you can't do that because there's a minus in front of the 27.
Yeah.
So if you actually do from left to right, 200 minus 27, 173, and you said 8 from that. The answer should be 165. Okay?
Yeah.
Yeah, does it make sense by 165?
Yeah.
Alright, good.
Right.
And let's do all of them. So it's
Okay.
B as well. So what's it become inside the brackets?
Still filling it out. Oh, inside the bracket. 15.
Yep, good. And if you can, Iman, try to show working. Can I see the way you're doing working? Because the thing with doing working like that is you can get a bit lost. What you should have is one main line of working, do things on the side. Don't make it a lot. To make mistakes. So what I have here is, look at this, right? So if I want to do calculation like this, because I already know the answer, that's why I didn't do it. But I would do it like 12 squared on the side myself. But I have a main line of working that I go flow one by one, replacing in order. It just becomes nicer to work with. Because I think you know that part mistake you made there in part A, that comes because you don't have the nice order.
Yeah.
So it's good to have one main thing and on the side doing some calculations.
Yeah, probably. Yeah.
Don't forget the 0. Second one.
Yeah. 892.
What's 4 times 15 squared? Oh, why is it 223? Also, you forgot the plus 5 at the end, but before that, 225, right?
225.
Because there's a 5 at the end here.
So I got this 15.
So it's 4 times 225, not 223. Because 15 squared is 225. I think you misread this. You got 225 written here, but you misread it as 223 here.
And then if I got the answer to that, and then plus 5.
Yeah.
I would have got my answer. Yeah.
So convert this to 3 to 5. 3 to 5 times 4. What do you get then?
894.
No, because you increase the number you multiply by 2. The answer doesn't increase by 2, it increases by a bigger number because you're multiplying a bigger number by 4.
Nine hundred.
900, yeah.
Which is 905 if you plus it by the 5.
So if you multiply these two, 4 by 2 to 5, that's 900. Add 5, 905. Alright, now this one's might be a bit weird for you because I don't think you do letters in year 5. But I want to introduce you to like algebra a bit. Right?
If we do what?
Algebra.
X.
Yeah?
Oh yeah, we do.
You do? Oh, nice.
We did it last year.
Algebra's pretty advanced then. Yeah. Because a lot of school starts year 6 maybe. Right? So you guys are ahead. Do you know what to do here? What's the question asking you?
It's asking like.
So you have an expression 3x minus 4 squared. You're asked to find the value of that expression when x is 5. So all you do is replace x with 5. So you have
35 minus.
No, it's 3x. Oh, so with letters, with algebra, 3x means 3 times x. With algebra, just letters. If it's like you can't have whole numbers. 3 2 is not 3 times 2, but 3x means 3 times x. That's just with letters.
So 3 times 5.
Yeah.
Minus 4, and then
Square that. So what's that going to be? 3 times 5 minus 4 squared.
11 times 11.
15 minus 4 is 11. Yeah.
Is 120. 121?
Yeah, 121.
Yeah.
Good. Nice. So that's that. So I'm just slowly building you up because we'll do algebra a little bit later.
Yeah.
This unit. So algebra is the most important thing in maths. So
yeah.
we got to ease our way into it.
Yeah, we're still doing like quite easy algebra now.
Yeah. Algebra, you go all the way to year 12 with algebra, so it's very important.
Yeah.
Alright, so I think getting pretty close to the end, to be honest. We only got up to here, so we're about 2 pages and a half away. So we're going to do squares of negative numbers and also negating squares, which don't need to worry about that for now. But the important one is squares of negative numbers, right? So if you, and remember, okay, let's recall the definition of this product. So the definition of square again was what? Because it's very important. I know you know.
A times A.
A times A. But we're gonna use it in a very clever way here, right? Not super clever, but it's. But let's first find out what 8 squared is. 8 squared is.
56.
No.
Oh no. How did I get 56? 64.
64. Yeah, it's pretty basic. Just want to warm up there. Now is when we get to this one. Negative 8 squared. What does that mean? So it's not. Don't think of it as division. It's just negative 8 squared, or think of this the brackets as or. Negative 8 squared, or in brackets in the number form. So what does that become?
This one.
Yeah. What do you think that is?
Negative 64.
Okay, so that's a very common misconception. What you have? But what's the definition of a square again? Negative 8 squared would be negative 8 times by what? It's a number by itself, multiplied by itself, right?
Oh yeah.
So negative 8 times negative 8. But then you have negative times negative.
So wouldn't it just be 64?
Yeah, it's positive 64. So that's a very common misconception. A lot of people think negative, or we're going to have a negative square number. But no, if you start negative, you square it, it becomes positive. Does that make sense?
Yeah.
So negative 8 squared is 64. So are you okay?
Yeah.
Okay. Does that make sense? So negative 8 squared is not negative 64, it's positive 64.
Yeah.
Right? But this one's slightly different. What's negative? What's this one? What's
negative 8 times times negative 8. Isn't it like the same as this?
Well, here what we had was negative 8 being squared. But remember BODMAS, what do you do first? The negative or the square first?
The square.
Yeah, because negative is the same as multiplying. Negative means multiply by negative 1. So you do the square first. When you do 8 squared, you get 64, just like we did from part A. But then you do the negative after that. Because negative means multiplication, remember?
Oh,
you do multiplication after you
do it.
powers. So its answer is actually negative 64. It's because the negatives are not inside a bracket. Here it was negative 8, the whole thing being squared.
Yeah.
Here you're squaring 8, then multiply by negative 1. Does that make sense?
Yeah.
So that's a very common misconception.
Yeah,
Yes?
you have to follow.
It's
Yeah.
where the brackets is. So
Yeah.
in general, this is a very common principle is when you square a negative number, it becomes what though? Like we need in part B.
Oh, positive.
Yeah, square of a negative number becomes positive. Very important. Actually ends up being the same as a squared. This rule is very important. Negative of a squared, negative a being squared, same as a squared. Because remember, these are the same. 8 squared and negative 8 squared are the same thing. So 8 squared and negative 8 squared is also, they're the same number.
Yeah, it's the same thing.
So they're negative. So if you square the negative, you get back the square of the positive as well. The same thing. Right? But this is a very common misconception we talked about already. If you square the negative, which this ends up being positive, but then if you square then negative, it's negative. It's the importance of the brackets. Right? Brackets make a difference. See how it's different? Here you square the negative number. Here you square the positive number, then you add a negative at the end.
Yeah.
Then that's different. Yeah?
Yeah.
Okay.
No.
Alright, let's do these two.
Yeah. Is this negation?
Yeah, negation at the end. Just trust what you've been doing before.
Yep.
Calculate it one by one. Do the square first, then you do whatever the operations after that. Oh yeah, but negation's the same as multiplication, by the way. In BidMass, it's not there officially, but negation is just like multiplying by negative 1. So that's why negation is the same position in the order. So you do squaring before you do negation.
Isn't negation like if it was negative 13, it would, the negation of that would be positive 13? Yeah. Okay. 199.
Careful.
9 3.
3 plus 3 is?
Did times again.
Oh, yeah.
Something with my multiplication. 169.
Good.
Which then is negative 169.
Yeah, because you square the negative, you get a positive, but then you negate that at the end as well.
It's 169 positive.
No. What's negative 13 squared? This thing ends up being positive, right? Negative 13, the whole thing being squared, becomes positive. But then there's a negation at the end. There's another negative. 2 negative signs.
Oh, so you have to apply it.
Yeah, at the end.
At the end, so yeah.
So you get a positive answer when you square it, but then you put
But
a
then-
negation on that. Puts it back to negative 169.
Yeah, so it'd just be negative 169.
So the answer to this one is 49 because it's
Yeah,
negative times negative.
positive 49, yeah.
This one's being negative of 169, which is just negative 169. That's our answers. Alright. Now we're going to do this inside some more trickier, not that tricky. But we'll do this page, yeah. Do these two. The page before, yeah.
do these two.
Yep. So remember, or follow bit mass. Do the squaring first.
Is it plus if there's no sign, or is it times?
It's times.
Yes, times.
Wait, what's 3? How'd you get such a big number? So you have 3 times 16.
Times?
Yeah. What does that become?
103 times
No. What do you do first?
this first.
So multiply. Oh yeah. Then you
Yeah,
do what?
and then it's 103.
But you added before you did multiplying. You added 100 to 3 before you did 3 times 16. Because here, look, if you did 4 negative 4 squared, you get 16. But if you look here, right? What you should do is bod mass or bid mass. Multiplication first, not the addition. You don't get 103 because that's addition. You do the multiplication before you do the addition. What you did there was we went left to right before you, but there was multiplication already, so you can't do that yet. So you can do the multiplication before you go left to right. That's why you got to be careful with bid mass. Slow, but slowly, little by
So
little.
it'd be 3, which is 48 times 100, which is 40.
Is it times? Plus in between.
Plus 148.
3 times 16 is 48. 100 plus 4. This is where bid mass is really important. Got to be careful with it, right? Here's what I recommend. I'll actually show you how I would I think what's happening right now is your method might be like making you make a little bit more silly mistakes. Try this way. I want you to try this one just for one example. If you don't like it, go back to what you prefer. So what I want you to do is approach a question like this. Okay, I need to do bid mass, so square first. Okay, 4 squared I can do that in my head. Negative 4 squared, same as 16, right? You can do that in your head, so I'm not going to do any working. But here, okay, 3 times 16, I don't know what that is in my head. Do a little side calculation. 16 times 3. Right, because I'm following bid math, I'm doing the multiplication first. Then I do side calculation. 3 times 6 is 18, 8, carry the 1. 3 times 1 is 3, plus 1, 4. Right? I get the 48 as my answer, then I replace that. Now this one I can add immediately, because it's 100 plus 48, 148. Whenever you have a step that's too hard to do in your head, go to the side, put a little working. Keep this neat, because then you can really see the bottom mass. You keep this neat, so you have this sort of line per line. Can you try that for this one? So you put on the side anything ugly, have this little nice light line working here. Just because I feel like you know what to do, but you're losing marks just because of the way you're approaching it.
So for this one, would I do 2 times this?
Yeah, but do that in 2 different steps. So just rewrite this thing, 300 minus 2 times 121, because you calculated one thing, replace it. So what I did here was, whenever I calculated a number, actually, let me do that first. I'm watching online thing. Right? If I do calculation here, I figured out negative 4 squared 16. I replace this negative 4 squared with 16. So I put it on the next line. So I would do the same thing. I figured out that that's 121. So I'd do the same line, but replace one thing at a time. Right? Once you're comfortable with this, do more steps at once. But this is the foundation of good working out. Right? And you can't do in your head, do on the side. Because you're getting to a little bit more advanced math now, so you know.
Is it 58?
Yeah, good. Right, it keeps the flow nicely. It can help your brain know what to do now. Let's get jumbled all over the place. Right, so you should go 11 squared is 121. 300 minus 2 times 121. Right? But if I need to find out 2 times 121 is, you probably did it, but let's say I do. Right? You can do a long multiplication on the side. So it's 2 times 2 is 4, 242. So I do that, replace that. 300 minus 242, you can probably do that in your head, I think. 58. So one by one, step by step. Very logical, very flowing, and it's really nice. So you make much less mistakes, right? So I want you to try this method, okay? Have these ugly calculations, because thing is, you're getting into the level of maths where it's not just one multiplication. You have a bunch of things going on in there. So you can have a logical flow in your thing, and you have all these sort of basic calculations on the side. And teachers can mark that pretty nicely as well. Okay, we've actually gone ahead of what we'd done yesterday, but we'll go a little bit ahead, right? Why not?
Yeah.
So 1/5 squared. So we're going to the squaring of reciprocals. What do you think 1/5 squared means?
Just could be 5 squared.
No, it's not exactly that. What's the definition of squaring again? Multiply a number by?
Itself.
Yeah, so it's 1/5 times by 1/5. That's what it means. Do you remember how to multiply fractions, basically?
Yeah.
So you multiply each part, the top and the bottom. So 1 times 1 is?
1 over 1.
Yeah.
Over 25.
5 times 5 is 25. Can you do the same thing here? The example in B. Yeah. Oh wait, negative times negative is positive. Don't forget that. The negative number being squared, so negative 1 on 7 times negative 1 on 7.
1 over 49.
Yeah, it's negative 1 times negative 1 is positive 1. 7 times 7 is positive 49. So it's plus 1 on 49. Very important. Okay, I want you to do the next 3 and then we'll finish up after that. Before that, I really recommend simplify inside as much as you can before you square. Very important for C. But you'll see it when you come to it. So do A, B first, then we'll go to C.
Let's see.
First one is good. Second one, what's the answer to the second one? This?
1.
Yeah, that's good. Yeah, good, perfect. Well done, great.
Okay.
Nice. You get the concept?
Yeah.
We'll finish up there.
Okay.
You got most of that? I think you, yeah. We still need just private so we can finish.